1. Do we want to? We probably can skip this one, I bet, right?
Sure.
I mean, we're just. What are the values? You can read them off to me real quick. What's A?
2, 1, 4.
Right?
Oh, yeah.
Okay. No big deal. Everybody get that? Questions on that? Okay. Okay. Choose the graph. Is this one worth looking at or not? Okay.
Please.
So that's fine. We'll look. Probably a lot of these are going to be graph ones. Now you got to be careful. So in Moodle, you've seen these problems, right? You're picking a graph, so you got to be very careful because this is one of those tests where there's not going to be a lot of room for partial credit on some of these, right? I mean, it's really what I would recommend if you're doing your work on the test. I would recommend maybe, yeah, having graph paper exactly. And I'm going to be expecting though once again on the test, I need you to on the yellow paper. It won't be yellow for this one. It'll be some different color. But I need you guys to write down which number goes with which word. Because it takes me, I mean, I don't want to be mean, but I'm probably, if you don't have that stuff on there, I'm getting to the point where I'm probably not going to take the time to grade. Right? I can't, I mean, it takes me so many hours to do this. I just can't take the extra time to try to match up problems with. So you got to at least do that. Right? Write the number down for each problem. And you can do the same thing with the graph stuff. The kinds of things you could do to get partial credit on these would be if you, well, I'll mention it as we go through this, right? You could do the same thing that we're going to do right now together. So we want to compare this to the template, right, to our standard form. What kind of function is this? Absolute value is the parent graph, right? So then we could write this as a transformation of our parent graph. So we could write it in the form A times x minus h plus k, right? Okay, so that's like our vertex form of the absolute value function. H and k are the coordinates of the vertex, A is the vertical dilation factor. So then you could just, for your work, you'd just be showing this stuff. What's A? What's H and K?
2 and 3.
Okay, so then all we got to do, if we want to graph this thing, we're just going to go, those are the coordinates of the vertex, over 2 and up 3, right? Okay, now to graph the shape of this thing. If the vertical dilation factor is -1/3, remember it's a factor. That's what I'm multiplying by the normal heights to get the dilated heights. I multiply the parent heights by -1/3 to get the dilated heights. So what are examples of the values I could choose? Well, for our parent graph, we go over 1 and up 1. We go over 2 and up 2, over 3 and up 3, over 4 and up 4. Which one's going to be a convenient one to multiply by our dilation factor? Any of them would work, but like if I pick this first one, if I multiply 1, positive 1, by -1/3, I'm getting a fraction. That's not very convenient. So 3 would be a good one, wouldn't it? So the one we would want to pick is probably this one, where the normal height is 3, right? And then all we're going to do is we're going to multiply, if I want to find the dilated height, I'm just going to multiply -1/3 times my normal value of 3 is going to give me a value of -1, right? So instead of going up 3, I'm going to go down 1. And my point would be there instead, right? And for an absolute value graph, these are just straight lines. All you need is 1 point, right? I know then that I'm going to go from my vertex, I'm just going to go through that point, and we're going to work smarter, not harder, using symmetry, because we know that this thing has an axis of symmetry, and so guaranteed, I'm going to get another point that's a reflection of this one, right over there, right? So there's my graph. Okay, get the idea? The part that in my experience, the part that people initially have a little bit of a hard time with is this part, right? Is applying that vertical dilation factor. But if you think about it in this way, it's very simple. It's a factor. It's what you're multiplying the normal height of the function. The height, when I say the height of the function, the height changes, right? But we're going to pick the height for a certain horizontal distance, right? So if I'm going 3 to the right, then the normal height is 3. That's what I'm multiplying by my dilation factor to get the dilated height. Okay? Makes sense? So what'd you do on Moodle? you're gonna look for the one graph that has a vertex at 2, 3 and goes through, let's say, for example, that point right there, right? If it has a vertex at 2, 3 and it goes through the point 5, 2, that's your graph, isn't it? Right. Okay, questions? Okay, yes ma'am.
On the test, can you like make it so the spaces between the lines and graphs?
I can't, unfortunately.
Merge together and I can't tell which one's.
Yeah, I know, that's kind of a pain. I can't. I've tried doing that and it doesn't work.
Wait, what's the question?
Can I make it so the graphs are separate? Unfortunately, I can't do that. I wish I could. It'd be nice if I could. Okay, so probably we can skip this one. Because I'm thinking we want to maybe do some quadratic ones right instead. Okay, we'll do the same process but for quadratic functions instead because they're a little tougher. Okay, write a function. So we do one. We'll come back to it if we need to. Okay, we'll come back to it if we need to. Okay, I'd say we could probably skip that too because we're going to do it anyway when we do a graph, right?
Okay.
Okay, so let's pick a little harder one of these. Okay, domain, actually we can do this one. So domain and range. You know what? We'll do it in the next one. I bet you, how about, you want to do this one? Yes or no? So if g of x is a transformation, right? So this is the same, all these essentially are the same thing. G of x is going to be a transformation of f of x, and we're going to use the same parameters, a, h, and k. Right, so then we're going to get g of x equals a times x minus h squared plus k, right? I just got to know what values am I plugging in for a, h, and k. So you tell me, what is this telling me right here? If I'm going to vertically compress f of x by a factor of 2/3, what's that saying?
That's our A.
Okay, good. So a equals 2/3. I'm going to vertically reflect. So what's that doing? What's that doing to a, h, or k? What's it doing? A is negative. So that's just making that negative, right? Okay, what about this one? What if I'm translating 5 units down?
That's our K.
That's k, isn't it? So that's telling us k equals what?
Negative.
Okay, and then finally, how about, we'll go around. What if we're translating 6 units to the left? What's that? -6 for h. I'm just plugging that stuff in, right? So then all I'm going to get here for my function, g of x equals, so a is -2/3 times x minus h. So what's x minus -6? Plus 6 squared plus -5 is just -5. See how nicely color-coded that is? Okay? Everybody got it? Okay.
Is that a
Okay,
maximum?
minimum or maximum, quick.
Maximum.
Minimum. How come? Because A is positive, right? So it's opening up, so it's a minimum. Good. Okay. Okay. It would be. If I wanted to write the equation, you know what? We'll see all this stuff when we'll do a bigger problem that includes all this. Like, how about that one? We get everything in that one, right? If we want to graph this guy, right?
Yes.
Okay, so then remember, we got to do domain and range too. Talk about domain and range on this. So what are the values of a, h, and k here?
-1/2 and -.
Okay, so that's my vertex, right? Everybody agree?
Yes.
That's my vertex. And so what is the equation of the axis of symmetry this time? Well, let's graph this thing first. So I go back 5 and down 3. There's my vertex. So what's the equation then of this axis of symmetry? Yeah. Right, there's the axis of symmetry, and it's just x equals -5. Okay? All right, so what's A is -1/2. So now we gotta draw the right shape of this parabola. It's gonna be reflected and compressed, but we don't even have to worry about that stuff, right? Because we just know that if A is equal to -1/2, I'm just gonna multiply that by the normal y values, the normal heights. So let's pick a convenient height. Now for our parent graph, we'd go over 1 and up 1. 1 times -1/2 is not super convenient. We could do it, right? If I go over 2, I go up what on a parabola? 4. I'm going up, right, I'm going over 2 and up 2 squared, because it's a quadratic formula, so quadratic function. So let's use that one. If I go over 2 and up 4, then that's what I'm going to multiply by -1/2 to get the dilated height. So what's 4 times -1/2? -2. Okay, so instead, I'm going to go down 2, right? And how did I get that? That's just equal to -1/2 times 4, right? And so because I've got this, I know I have a point there, and because I've got this axis of symmetry, I know that I could reflect that over the axis of symmetry to get another point on the other side, and so this one's just going to look like that, isn't it? So which one do I pick? I pick the one that goes through the point, has a vertex at -5, -3, and goes through the point -3, -5. Right? Okay, what's the range of this function? Let's write all this stuff down. So the domain is what? All reals. Okay, what about the range?
Less than or equal
Less than or equal to -3, because that's the vertex, right? This is one that opens down, so the vertex is going to be a maximum this time, not a minimum. So we just get y is less than or equal to -3, and we get that -3 from here. Okay? Good? What if I want to reverse that and I want to write a function in this form? Okay, so that means I'm just going to pick out, I just need to plug in values for a, h, and k. So what's h and k? -5, +4. Okay? And then I need a.
Is it 4?
Okay. It is. It's 4, but how come? So we got to think about why. Here's a way to think about this. So this is one. This might be one everybody might want to look at. It's up to you. But I know that the dilated height is 4, right? So what does A do? A is going to multiply. I'm going to take the parent height times A is equal to the dilated height every time, right? Everybody agree? Okay. So if I'm trying to find the parent height, I know what the parent height is, I know what the dilated height is, I want to find out what A is. So in this case, the dilated height is 4. What would the corresponding parent height be? If I went 1 to the right, what would I normally go up? 1, okay? So the parent height would normally be 1. So I've got 1 times A equals 4. What's A? 4. There you go. Done. I got 4 for A. H is -5, K is 4. Plug them in. We're done. Okay? Questions? Okay? Same thing. Same thing. This time, okay, let's only focus on A this time. This is a little bit tricky. So for this one, I went to the right by 1, 2, 3, 4, 5. And my dilated height is 5. Okay, what would my normal height be if I went 5 to the right? 25. I'd go up 5 squared. So then the equation we get is my parent height equals A times, sorry, the way around. Got backwards. My dilated height, 5, equals A times 25. Right? I multiply the dilation factor times my parent height to get the result, the dilated height. So what's A equal to? 5 divided by 25, which is what?
So do you get the
Okay.
25 from multiplying?
No, I get it because I know that my parent function, if I pick points on my parent function, I go over 1 and up 1, I go over 2 and up 4, I go over 3 and up 9, I go over 5 and up 25. Yeah. Okay. Okay? And then you can always just do a logical check. Does that work? Well, yeah, this has obviously been compressed a lot, hasn't it? Right? So it's 1/5 makes sense. Okay, this is no big deal. All this is, what's the greater than? F of x is greater than. What? It's an inequality. What am I doing? I'm just shading everything above the parabola, and the parabola would be dashed. Okay? Right? Okay, what's the value of C that makes a perfect square trinomial? Yeah. So it's going to be B over 2 squared equals 121/4. Okay. What would okay, so if I turn this into a perfect square trinomial by completing the square, what's the factor I'm going to get? If I write this in factored form, I get x, what? Plus what? 1/6. How come? Because it's half of b. What's half of 1/3? Well, 1/2 times 1/3 is 1/6. Okay. Okay, let's skip that. Okay, we could do this one. So if I set this equal to y, I'm just going to complete the square. Okay, I got to get the right side equal to x squared plus bx. So what are the steps I got to do? Add 2. Now what? We divide everything by -3. So I get that? Okay, good. And what I would have you do here is I would say, okay, what are we going to get down here? I know I'm going to get x plus 1 squared, but to get there, I've got to add 1 squared to both sides, right? Okay? And so now I've got the equation. Now I can just, I completed the square. On the left side, I've got 1 plus the quantity y plus 2 over negative 3 equals the quantity x plus 1 squared. So what are the steps to get y by itself? What do I do first? I subtract 1, good. And then I've got y plus 2 over negative 3 equals x plus 1 squared minus 1. Now what? Multiply by negative 3, okay? And I got to distribute that to everything, don't I? Right? So then I get y plus 2 equals negative 3. Do I try to distribute that inside? Cannot do that, can I? Because it's being squared. So I get negative 3 times the quantity x plus 1 squared, but that's good because that's just a, isn't it? Right? And then plus 3, last step, subtract 2.
Where did you have to?
Say it again.
Where did you get the added 3?
Because I distributed, right here, I distributed the negative 3 to the negative 1. Okay? And then finally, if I subtract 2, I just get negative 3 times x plus 1 squared plus 1. Okay? Good? All right. Okay. All right, so let's skip up to, yeah, like those two. How about that one? Okay. So if I want to choose the graph of this quadratic function, what are my options here? I mean, I've got two things I could do. And really, let's backtrack for just a second. Like, we could have gone a different route with this too, couldn't we? What's our final answer? We did all that work, and this is what we got, correct? Okay, I'm going to show you plan B on this. So after completing the square, we got that result, right? What else could you have done? If I want to put this into vertex form. Yeah, I mean, we know vertex form is just y equals ax squared plus bx plus c, right? I mean, ax squared times quantity x minus h squared plus k, right? So we know that we could just find the values of a, h, and k and plug those in, right? So we can do that without actually completing the square, too. I think completing the square is a little quicker myself. Once you get good at it, I think it takes fewer steps. But we could figure out, well, A we already know. What's A? That one's free, but we got to find H and K. So H equals negative B over 2A. What's that going to give us? 6 over negative 6. Right? Which is negative 1. Okay? K is just f of h, right? We plug h in to find k. So we're getting f of negative 1, which I can plug in up there. And in this case, maybe it's quicker this way. Okay? And what's that give us? Negative 3 plus 6 minus 2, so 1. Well, what do you know? If we plug that stuff in, isn't this what we get? I'm getting negative 3 times x minus negative 1 squared plus 1 if I plug all those things in, right? So either way. Which brings us to this last problem. So what are my options? Well, I could complete the square with that if I want to, or I could just find the values of A, H, and K the way we just did, right? And either way, all I gotta do then is create my graph. Okay, so what if we, what do you think? We'll take your pick. Which way do you like better? Doesn't matter. Either, okay? If we have time, we'll do both, but I'll start off just doing the H equals negative B over 2A method, okay? So what are the values of A, B, and C here? Oh, sorry, I got sidetracked. Thinking ahead, not paying attention. Okay, now, so we can figure out, we know what A is, that's already set. H equals negative B over 2A, so what's that gonna give us? So positive 3, because I got a negative B is positive 3, divided by 2 times negative 1/4. So I get 3 divided by negative 1/2, is that right? 2 times negative 1/4 is negative 1/2. Dividing by negative 1/2 is the same as multiplying by negative 2, right? So H equals negative 6. Okay? And then to get K, I would have to just plug that back in up here, wouldn't I? Right? So to get K, I get F of negative 6. So that's going to give me negative 1/4 times, what's negative 6 squared? 36. Minus 3 times negative 6 minus 12. So I get negative 1/4 times 36 is what, negative 9? Plus 18 minus 12, so I get 18 minus 21 is negative 3. Everybody agree? Now I got them all. There's K, there's H, there's A. So all I've got to do is, my vertex is going to be at HK, so it's at negative 6, negative 3. And if A is negative 1/4, okay, let's think about that one. If A is negative 1/4, what's going to be a convenient parent height to transform? Okay, 4. So I could normally go over 2 and up 4, right? If I go over 2, I would normally go up by 4. So we would just multiply 4 times negative 1/4, right? And what's that equal? 4 times negative 1/4 is negative 1. There you go. So instead of going up by 4, we're just going to go down by 1, and that's all we need, right? There's our parabola. Okay? Right?
Yeah.
Okay? So we could have done that also if we wanted to. I'll just do, I know this is probably overkill, but I'm just going to get you extra prepared here. We could have also just put that into vertex form. So you can pay attention if you want to. I'll just go through the steps. So we got it equal to y. I know, I probably you're thinking, why would you ever do that? But honestly, if I were doing this, I would complete the square. To me, that's easier to do. It really is. I feel like I could do that faster than I can the other stuff if I'm doing it myself. And you may not be there yet, but you will be if you keep working at this. So, what would I do then? Add 12. Now what? Okay, but dividing by negative 1/4 is the same as multiplying by negative 4. Now you'll see how easy this is, I promise you. Watch this. So then what am I going to get? If I do that, I get negative 4y minus 48 equals x squared plus 12x. Look how easy this is going to be.
Would you do that about whole number or was it
Say it again.
if your A was a whole number, would you just?
Then I would divide.
Well,
Yeah.
could we times by a fraction of what either way?
Say it again.
Could we times by a fraction?
Same thing. Same thing. Yep. Dividing by 4 is multiplying by 1/4.
Okay.
Okay, so what number would I add to both sides?
48?
No.
6.
What is 6 squared? Good.
Oh,
So
okay.
I'm adding 6 squared, which is just 36, which is going to give me over here x plus 6 squared, right? But on the other side, these things combine pretty easily. I get negative 4y minus 12. Everybody agree? Okay, so last two steps. Got to get y by itself. Add 12. And then either way, multiply by negative 1/4 or divide everything by 4. Let's do this one because we always divide. Let's just multiply by negative 1/4 this time instead and distribute that. Right? So we end up getting y equals, if I distribute that, negative 1/4 times the quantity x plus 6 squared. So there's my a and there's my h, right? And then I get a minus 3.
Wait, in the,
Same thing we got before, somewhere.
wait, in the,
Sure.
so when you went from what x squared was 12x plus 6 squared, you can push 6 on one side, and then the next step, what did you do?
Okay, so I this. Yeah, I see what you're saying. So all I did here was I just combined those two things. Right?
But like, if you have like, the negative 2x, something you divide by negative 2, 6.
So if one of these was a fraction,
Yeah.
then that's up to you. You never have to combine them. I could just do it. Say it again.
Like the one where you put like, the 4y minus 3 over 2.
Mhm.
Maybe when it's
Okay.
because it's.
Because of the, right, okay, so I see, so did we do one, I think we did one like that earlier. Let me go back to that previous example and I'll make a point. Where did we do that? Not there. Right there, okay? Like if we were graphing, if we were doing this one, you're talking about this step right here, aren't you? Right? So we would subtract 1 from both sides, and then you're at this point, right? Okay, you have an option. I could distribute that negative 1/3 and get negative 1/3 y minus 2/3. But I just don't want to do that because then I'm having to deal with all those fractions. It would work, but it's easier just to say, okay, if I'm going to isolate y, I have to reverse order of operations. So you'd multiply first because these are in implied parentheses.
Right, I've been doing weird.
Show me an example. I'm done now, so just bring one up and I'll see if I can find your mistake. Okay? Make sense? Okay. It's recorded if you want to look at it, but there it is. Uh-huh.